When setting up a fiber job directly in the LANTEC, we need to change to the advanced user interface, select a job to test in or create a new job, and then add tests to that using a specific type of standard for fiber. So we'll go to the preferences screen first and change our operation mode to advanced. Press continue. And that brings us to a blank screen where we can see currently our job is Fiber 2, but there are no tests defined in this job yet. So I'm going to go to the jobs icon, and our active job is shown in blue here, Fiber 2. I can make different jobs active by pressing and holding. In the pop-up menu, I can choose set as current job. So if I choose that for this job, now FiberTEK IV becomes the job that we'll save tests into. So let's go ahead and leave it like that. Now we need to go into the job by tapping on it and add tests by pressing the plus icon. And then we'll choose copper or fiber. We want to do fiber. So we get presented with the test prefix and the range. So we have A01 to 01. So that's my default setting that I have in this tester, A1 to 1. So let's say we want to do 2 tests. We'll just change that 01 to 0. I'll make it 06 for 6 different tests. Backspace 6. And now let's scroll down to the test configuration window. We'll tap on that, and you can see my current default we'll get back real quick. My current default was 568D.3 2019 OS 1. So we want to change that. That's a single mode test. So we'll change our cable type. We're doing OM4 cable in here. So we'll choose OM4. Now for the test type of standard, we can choose cabling standards, application standards, manual loss budget, or budget loss calculator. Cabling standards is what most people are going to use, and that's where we're using ISO, IEC, or Senelec groups, or ANSI TIA standards. And these are standards that the cabling standards organizations put in place for generic fiber optic cabling. The other options are application, manual, and calculator. So if you look at application, this is going to be if you know what particular bandwidth or speed needs to be tested on that cable. So a most common group would be IEEE Ethernet, and then I can choose the application here, and we have a mix of 10100, 1000, we have 10 gig, 40 gig. So there's various applications here. So if I wanted to do 40 gig on, we're doing multi-mode here. So 40 gig SR4 is multi-mode, and that's going to tell us the limit is 1.50 dB at 850 nanometer. And you'll notice for 1300 nanometer, it's 0 because that application is only run on 850 nanometer. Now we'll test both wavelengths, but we won't apply any pass-fail criteria to the 1300 nanometer. We'll only check the 850 nanometer. And the max length for this application is 150 meters. Let's go back and change it to the manual loss budget, which is quite simple. You can just input the value that if you know what the maximum loss can be. So first thing you can do is choose either wavelength or both wavelengths. So if we want to do just 850, we can just type in the loss budget here of, right now it's set to 0. So let's say we are allowed to have 2.0 dB of loss for this particular project we're working on. So we'll type in 2.0, and the length is optional. So we can have it measure the length, and with just that box ticked, it will measure the length, but will not give us a pass-fail limit. So it's just for information. If we want to add a limit there, we can tick that box, and the default is 1,000 meters. So maybe we want to change that to be 100 meters. And so now the test will run, and it will check to make sure that 850 nanometer is below 2.0 dB. and the length is 100 meters or less. And that will be our pass-fail criteria. The next option we can look at is the loss budget calculator. Now, this is somewhat similar where you don't know the maximum loss, but you want to have it calculated based on the length of your cable. So we have 850 nanometer, the 2 dB is set there from where I set it before. We need to specify which type of test cords we're using. Are they standard grade or reference grade? So the ones that we have here are reference grade. We'll leave that selected. How many couplers or adapters in total are in the cabling you're going to test, including the couplers at the end of your test cords if you're doing the one jumper test method, then that would be 2. And if there's any additional couplers in the system or patch panels or something like that, you would need to add them. So let's say we had 1 additional patch panel in this link. So we'll just change that to 3. So we have the 2 couplers from our at the end of our test cords or at the panel, and then we'll say there's 1 more panel. So there's 3 connectors in total. And now we can specify the number of the amount of loss for each connection. The standard is 0.75 dB. If there were splices in here, we can measure that. So if you had a pigtail splice from changing from different types of cable or to terminate the cable, you can enter the number of splices and how much loss for each of those. And again, we can choose to measure the length if we like. So I'm going to back out of here and just go and change this back to the OM4. We'll go with the cabling standards, TIA, and the standard is the ANSI TIA 560.3-D 2019. So that gives us that limit. We need to choose the number of adapters. So again, we have 2 standard adapters, and we don't have any splices in this cabling. And the maximum length by default is 2,000 meters. So we'll go ahead and hit the tick mark up here. And now we need to choose the test mode. So we're doing normal mode, which means main handset to remote handset. We're doing a 1 jumper calibration. That's fine. The connector type we're going to test is LC, and we're going to use encircled flux launch cords here. Okay. And the refractive index, if we know it, we can enter that in here. Otherwise, we could have chosen from the cable type. If you choose a brand of cable, the refractive index will be set for us. So refractive index is the equivalent of NVP that we use on copper. That's the equivalent on fiber. So it tells you how fast light is traveling through the fiber itself. So once all these options are set correctly, we'll hit the tick mark here. And so we're going to have test A-1 through A-6 using this configuration shown here. Let's hit the tick mark one more time to confirm it. And now we have our 6 tests loaded into our test list, and we are ready to set up our jumpers, do our set reference, and begin testing. So we'll look at that next. So we now have the FiberTEK set up and calibrated with our encircled flux launch cords. I've already got the remote handset connected at one end of this LC fan out cable. And on the second hand, on the main end, I wanted to demonstrate to you which end should go on which fiber you're testing. The receive cord, so this blue cord is going to the receive port of the Lantec, and this orange cord is coming from the transmit port from the encircled flux module. This is a typical SFP fiber module. This is a 10 gig one. And the left port on here is the transmit port, and the right port is receive. So this is the transmit port, meaning light is coming out of here. So when we are plugged into our patch panel, our duplex LC ports, the left port is where the light would be coming out on the active network. So I'll insert the receive cable on the left and the transmit cable on the right. I already have the remote side hooked up here. Same orientation, receive on the left, transmit on the right. And that's because these cables, the installed cabling has the flip, the reverse from A to B already in it. So I should hear when I plug in this last cable, the chime indicating that the partner finder is working and that my polarity is correct. So I line this up and insert it. And there it is. So there's my chime. So I know my polarity is correct. I have receive on the left on both sides, transmit on the right on both sides. And on the handset, the option to test has turned blue. So I can just, now that those are network connected, I can run through and run that test. And when that's finished, then I can go to the next set and the next set and the next set and run through my 6 different fiber connections here on this panel. Thank you for watching. Have a great day.